Okay, so for number 8, we're going to use the same formula that we did back in number 4 when we calculated the monthly payment, but now our time is going to be 15 years instead of 30 years. So the only thing that's going to change is right here. All right, so let's set that formula up again. It's going to be 45,000 Again, we don't know our payment amounts, but we still have the same interest rate. We're still making monthly payments, but instead of 30 years, it's 15 years. All right, so again, let's cheat just a little bit. We can look up and see what 1 plus 0.0325 divided by 12 was in our prior, and here it is. It's 1.0027083333. So 1.0027. Zero, 8, 3, 3, 3. This time, though, that is to the negative 15 times 12 power, which ends up being negative 180 instead of 360. And then remember on the bottom, this right here is just this without the 1.0027083333. All right, so now let's take this and raise it to the negative 180. Remember when you do so to put that entire exponent in parentheses. And that gives me 0.6145. Oops. That is a decimal right there. 64757. Next, in our calculator, let's take 1 minus this number. I get 0.385435 243. And now we want to take this top number and divide it by the bottom number in our calculator. I get 142.3145 687. All right, so last step, let's solve for D. Let's divide out the number that's being multiplied by it. So on both sides, I want to divide by 142.3145 687. And my payment ends up being $316.20. Okay, now we're not done answering the question. Let's also notice that we're supposed to calculate the total interest saved. All right, so let's remember that we are now paying $316.20 a month for 12 times a year for 15 years. So let's see what we actually end up paying. So we actually end up paying $56,916. Okay, now, so the interest we end up paying is $56,916 minus the amount that we financed, $45,000. And that ends up being $11,916 in interest. Now let's compare that amount of interest to what we paid when we were doing the loan for 30 years. Did I lose that calculation somehow? That's weird. It did. It disappeared on us somehow. That's very bizarre. Okay, I'll calculate it real quick then. Okay, so here it is. I don't know where it went a minute ago. So we paid $25,502.40 in interest when we were paying for 30 years. All right, so let's go down here, 25,000. So if we subtract 25,502.40 minus, for 15 years, it was $11,916, we would have saved $13,586.40 if we financed for just 15 years. Okay, so let's now look at question 9. To save up for the $10,000 or 10% down payment from question 3, which for us was $5,000 a while ago, you decide to open a savings annuity. Your bank offers one earning 2.5% compounded monthly. Decide how much you can save each month, and then calculate how long it would take you to save up for your down payment. All right, so my down payment was $5,000 way back up in the previous question. So we're going to use the saving annuities formula. Okay, so let's fill in. My future value is the $5,000 down payment that I'm saving up for. Let's suppose that I can afford $200 a month. Now that's totally up to you. Your amount might change. So I'm going to say that I can afford to pay into this account $200 to save up for my down payment. So that's what I'm putting there. That may be different for everybody. All right, now my interest rate is 0.025. We're going to put these payments in monthly, these deposits, and we want to know how long. So our N is what we don't know. So this is going to be similar to the problem that we used the logs for earlier. And then on the bottom, again, I have 0.025 over 12. All right, so first thing, I'm going to do a lot of things. I'm going to get rid of this 200 first, so I can actually divide it out here and divide it out here. This cancels out, and over here I get 25. Now, while I'm at it, on this side, I don't need parentheses anymore because this is gone, but I'm going to do 1.025 over 12 in my calculator. And that ends up being 1.002083333. And let's remember this is still to the 12n power minus 1. And then I'll do the bottom calculation. 0.025 divided by 12 is just this without the 1. So it's 0.0027. 0, 8, 3, 3, 3. All right, now, next step, let's get rid of the number that is in the denominator. So I'm going to multiply both sides of the equation by, well, I can't draw this number. And this side as well. So on this side, this will cancel out with this, but over here, let me put 25 times this number into the calculator. I get 25.052 08333. Okay, let me correct that. I thought that did not look right, so I re-entered it, and I think apparently I accidentally multiplied this number by this. Okay, because I had it in my calculator already. The actual amount is 0.052 08325. All right, and then over here I now have just the top of what was in the top of the fraction there. All right, next, let's get rid of the -1. So we're going to add 1 to both sides. That gives me 1.052083325, and of course the 1's cancel. And now we're going to use our logs like we did in that previous problem. So we put a log on the front of this one. And we put a log in the front of this one. And I will let this, the calculator do log of 1.052083325. So the calculator gave me this decimal. And then remember, the logarithm allows me to take the exponent and move it to the front, which is what I've done right here. So now I'll let my calculator do log of 1.0020833. That gives this number, and let's go ahead and multiply this number times the 12, which gives 0.0108465051 times n. And our last step is to divide out the number that's with our n on both sides, and that's going to tell us the amount of time it takes to save up this $5,000, which I would expect it's between 2 and 3 years, but we'll see. So I get in the calculator that it's 2.03, slightly more than 2 years to save up to get the $5,000 down payment.